Physics is a broad subject. It covers many different topics. At one end, it studies phenomena at the very small scale of length, that is 10 to the power minus 14 meter or even less, involving electrons, protons, etc. At the other end, it deals with astronomical phenomena at the scale of galaxies or even the entire universe, whose extent is of the order of 10 to the power 26 meter. In short, the domain varies from microscopic to the macroscopic levels. In this video, I will be describing various branches of physics. Let me begin with describing classical mechanics. Classical mechanics is one of the oldest and largest subject in science and engineering and technology. Classical mechanics deals with the motion of bodies under the influence of forces or with the equilibrium of bodies when all forces are balanced. It is also widely known as Newtonian mechanics. Newton's laws of motion describes how everything made of matter moves about. Newton's law of universal gravitation binds together the motion of planet around the sun. It also describes why object falls back on Earth after throwing upwards. Newton was also credited for the discovery of calculus. Calculus is one of the important mathematical tools used to describe physics. Physics and mathematics are inseparable. In fact, mathematics is the language of physics. Electricity and magnetism, combinedly known as electrodynamics, deals with electric and magnetic phenomena associated with charge and magnetic bodies. Its basic laws were given by Coulomb, Oersted, Ampere, and Faraday, and encapsulated by Maxwell in his famous set of equations known as Maxwell's electromagnetic equations. The motion of a current-carrying conductor in a magnetic field, the response of a circuit to an AC signal, the working of an antenna, the propagation of radio waves in the ionosphere, etc. are problems of electrodynamics. Optics is a branch of physics that deals with the phenomena involving light or electromagnetic radiation and its interaction with the matter. Optics includes the study of sight, the working of telescopes and microscopes, colors exhibited by the thin films, etc. are topics in optics. Thermal physics is the combined study of thermodynamics, statistical mechanics, and kinetic theory of gases. It deals with systems in macroscopic equilibrium and is concerned with changes in internal energy, temperature, entropy, etc. of the system through external work and transfer of heat. The efficiency of the heat engines and refrigerators, the direction of a physical or chemical processes, etc. are problems of interest in thermal physics. Another important topic is atomic and nuclear physics. Atomic physics is a branch of physics that deals with the composition of the atom apart from the nucleus. It is mainly concerned with the arrangement and behavior of electrons in the shells around the nucleus. Whereas nuclear physics deals with the constituents, structure, behavior, and interaction of atomic nuclei. In the modern age, nuclear physics has become very wide in its scope and has been applied in many fields. It is used in power generation, nuclear weapons, medicines, magnetic resonance, imaging, industrial and agricultural isotopes, etc. Solid-state physics and electronics. Solid-state physics, the largest branch of condensed matter physics, is the study of rigid matter or solids. It includes the study of semiconductor and their properties, whereas electronics deals with the study of the flow of electrons and their effects in a vacuum, gases, and semiconductor materials. It is also concerned with the design of circuits using transistors and microchips. The most important topic of physics in the present era is the quantum mechanics. In the beginning of the 20th century, it was realized that Newtonian mechanics, till then a very successful theory, could not explain some of the most basic features of atomic phenomena. Similarly, the then accepted wave picture of light failed to explain the photoelectric effect properly. This led to the development of a radically new theory known as quantum physics or quantum mechanics to deal with atomic and molecular phenomena. Quantum theory is currently accepted as the proper framework for explaining microscopic phenomena. Quantum physics will play an important role in future technologies, for example, computers. We are on the cusp of a new era of computing with Google, IBM, and other tech companies using a theory launched by Einstein to build machines capable of solving seemingly impossible tasks. They are surely to revolutionize the future of computing. I hope you like this video. If you have any queries, mention it in the comment box. Please like, share, and subscribe our channel to learn more. Thank you.